Okay, in this video, we'll talk about section 9.3 dealing with applications and probability. The only thing we'll look at is calculating odds in favor of and odds against events. Also, we'll use odds to calculate the probability of an event and also calculate the expected value of a random variable. All right, so we'll begin with what odds mean. Make specifically odds in favor and odds against. Usually people talk about odds in favor of and odds against a particular events happening. Usually that's found in when people place bets at racetracks. Those are where odds in favor and odds against are used. Odds in favor refers to the ratio of showing how likely an event will happen relative to how likely an event will not happen. Whereas odds against is just the reciprocal of odds in favor. It refers to the ratio of showing how likely an event will not happen relative to how likely an event will happen. So these two are just reciprocals of each other. And you'll see that formally as we define odds. And in this case, if I let the probability of event A be that probability that A occurs, and P with the A bar, that's the complement of event A, the probability of A complement, that's going to be the probability that A does not occur. Then the odds in favor of an event will be this. The probability of event A divided by the probability of A complement. Or by defining what the complement of the probability, well, the probability of the complement of event A, that's going to be this, 1 minus the probability that A occurs. So probability of event A divided by the probability of A complement would be this. Probability of event A divided by 1 minus the probability of event A. And the odds against event A would be this. It's just a reciprocal, as you can see. Probability of A complement divided by the probability of event A, or we can say 1 minus the probability of event A divided by the probability of event A. So as you can see, these two are just reciprocals of each other. Okay, so if we're dealing with equally likely outcomes, the odds in favor will be the number of favorable outcomes divided by the number of unfavorable outcomes. And then the odds against will be just the reciprocal, as you can see, the number of unfavorable outcomes divided by the number of favorable outcomes. Okay, let's look at this first example here. Excuse me. Here we got 2 dice are rolled, and I want to find the odds in favor of rolling the sum equaling to 6, and then greater than 4, then less than or equal to 8, and that it is an odd number. Okay, and here we got the sum and their counts that are given. All right, let's first add up the count total here in this right-hand column. So if I add 0 and 1 plus 2 plus 3 plus 4 plus 5 plus 6, then 5 plus 4 plus 3 plus 2 plus 1, I end up with 36. So the total count would be 36. And then I can answer part A. Let's first find the probability of getting a sum equal to 6. That would mean if I look at the sum of 6, how many ways that I can get a sum of 6 to count would be 5. So the probability of getting a 6 would be 5 out of 36. And then the odds in favor of a 6 would be this. The probability of getting a 6 divided by 1 minus the probability of getting a 6. So here I'm using this formula for odds in favor. Probability of getting a 6 divided by 1 minus the probability of getting a 6. So the probability of a 6 would be 5/6 divided by 1 minus 5/6. Well, 5/6 is in the numerator divided by 1 minus 5/6. If you use your calculator, you'll get 1/6. And I'll go ahead and show you 1 minus 5 divided by 6. Press the math key. And then okay, sorry. Oh, there we go. 1 minus 5 divided by 6. Press the math key, number 1. You'll get 1/6. And we can do 5/6 divided by 1/6 in the calculator. Notice I'm putting the numerator and the denominator in parentheses. You'll get 5. But here we write that as 5/1. And of course, and when we write something for odds in favor or odds against, we use the 2 dots, which is a colon, 5/1. So the odds in favor of rolling the sum equaling to 6 will be 5/1. That's the answer to part A. Part B. Let's say we want to find the odds in favor of rolling a sum greater than 4. So the probability of getting a sum greater than 4. Let's see. Greater than 4 is this. We can't include 4. We have to include these numbers that are greater than 4. So that means, in this case, I'm going to cover up the 4 because I cannot include 4. I have to include these numbers, 5, 6, all the way down to 12. So I need to add these numbers here. 4 and 5 is 9, plus 6 is 15, plus 5 is 20, plus 4 is 24, 27, 29, 30. So the probability of getting a number greater, getting a sum greater than 4 would be 30/36, which reduces to 5/6. So now we want the odds in favor of rolling a sum greater than 4. So the probability of getting a sum greater than 4 would be the numerator 5/6 over 1 minus 5/6. Well, that's the same thing, 1/6. And that's going to reduce to 5/1, which we write as 5/1. So the odds in favor of rolling a sum greater than 4 would be 5/1. Now part C, less than or equal to 8. So I need the probability of rolling a sum or getting a sum less than or equal to 8. So less than or equal to 8 means numbers including 8 and anything less than that. So we need to just count these numbers. So here, if I add 5 and 6, that's 11, plus 5 is 16, plus 4 is 20, plus 3 is 23, 25, 26. So the probability of rolling a sum less than or equal to 8 would be 26 out of 36. Let's see if I can reduce that. And in this case, I can. This will be 13 over 18. Yeah, 13 over 18. So now the odds in favor. Odds in favor of rolling a sum less than or equal to 8 would be this. The probability of getting an 8 would be 13 over 18 minus, again, a number less than or equal to 8 would be 13 over 8 minus, divided by 1 minus 13 over 18. So I'm still using this right here, the odds in favor. Probability divided by 1 minus its probability. So this would be 13/18 divided by 1 minus 13 over 18. As a fraction, it'll be 5 over 18. But here, these 18s are going to divide out. You'll be left with 13 over 5. And if I write that as a ratio using the 2 dots, 13 to 5. So the odds in favor of rolling a sum less than or equal to 8 will be 13 to 5. All right, and then part D, finding the odds in favor of rolling a sum that is an odd number. So our sum has to be an odd number. We need to include numbers like 1, 3, 5, 7, 9, and 11. Because those are sums that are odd number, that are an odd number. So, see, probability of an odd sum would be this: 0 plus 2, that's 2, plus 4, that's 6, plus 6, that's 12, plus 4, that's 16, plus 2, that's 18, out of the grand total of 36. So if I reduce 18 over 36, that's going to be 1/2. So the odds in favor of that happening would be the probability of getting an odd sum that's 1/2 over 1 minus 1/2. 1 whole minus 1/2 will be 1/2. This will reduce to 1 over 1, which will be, in this case, 1 to 1. So the odds in favor of rolling a sum that's an odd number would be 1 to 1. Or in some cases, we call that even odds. Because that's what 1 to 1 odds mean, even odds. Okay, now let's look at this next example. If the probability of a child being a boy is 1/2 and a family plans to have 5 children, what are the odds against having all boys? Okay, let's first find the probability of having 5 boys. Now, in this case here, the births are going to be independent, meaning the birth of one child will have no bearing on what the birth of the other children would be. So, probability of getting a boy would be 1/2. For 5 boys, we take 1/2 and multiply it as a factor 5 times. So this would be 1 over 2 times 2 times 2 times 2 times 2 would be 32. So the probability that a family will have 5 boys would be 1 over 32. Now we want the odds against 5 boys. This time, it's going to be 1 minus the probability of 5 boys divided by the probability of 5 boys. So now we got to have 1 minus 1 over 32 divided by 1 over 32. Now, if you want me to do this in calculator, that's fine. It'll be 1 minus 1 divided by 32. And notice it's in parentheses. Press the math key. Number 1 for fraction. We'll get 31 over 32 divided by 1 over 32. And the 32 in the numerator and the denominator will divide out like that. And you'll end up with 31 over 1. And it's important you have the 1 there because when you write it like this, it has to be 31 to 1. So the odds against 5 boys, the odds against a family having 5 boys, if they plan to have 5 children, would be 31 to 1. All right, next is this example. Say I want to find the odds against a randomly chosen household having a cat. If the probability of an event that a randomly chosen household has a cat is 0.37. So the probability of having a cat is 0.37. Let me write that as a fraction, which would be 37 over 100. Now, if you want to, you can leave it as 0.37 when you do the odds against a cat. Because we're dealing with odds against this time. Odds against having a cat. Would be this. 1 minus the probability of having a cat, which is 0.37, divided by the probability of having a cat, would be 0.37. 1 minus 0.37 would be 0.63, divided by 0.37. Now, in this case here, I'm going to, since we're dealing with decimals here, each one of them are 2 places to the right, so I will multiply the numerator and the denominator by 100. So 100 times 0.63 would just be 63 over 100 times 0.37 would be 37. So the odds against having a cat for a randomly chosen household would be 63 to 37. Okay, so that's how we do odds here. All right, and here's some more examples of just that. From a set of 7 marbles, 4 green and 3 white, we choose 1 at random. What is the odds in favor of choosing a green marble? Well, first of all, this is part A. First of all, I need to find the probability of getting a green marble. And we need to find out how many green marbles do we have. There are 4. And it's from a set of 7 marbles, so it's going to be over 7. So the probability of getting a green marble will be 4 sevens. And from that, we can find the odds in favor of choosing a green marble. That would be the probability of getting a green marble, which is 4 sevens, divided by 1 minus the probability of getting a green marble. That's 4 sevens. So I have 4 sevens in the numerator. 1/7 minus 4 sevens. 1 minus 4 over 7. That would be 3 sevens. And what's going to happen here is that these sevens will divide out. So I'll be left with a 4 in the numerator and a 3 in the denominator. So this will be 4 for 3, but we write that like this, 4 to 3. So the odds in favor of choosing a green marble would be 4 to 3. Now in part B, we want the odds against choosing a green marble. The odds against choosing a green marble. Well, if I know what the odds in favor of choosing a green marble, that's going to be 4 for 3. The odds against choosing a green marble would be just the reciprocal of 4/3, which is 3/4. Or in this case, 3 to 4. So the odds against choosing a green marble would be 3 to 4. So all I did there was just take the reciprocal, because in fact, the reciprocal of anything for odds in favor would be odds against, and the other way around. Okay. All right, now the next example dealing with odds would be this. If the probability of an event happening is 83 over 98, what are the odds against it happening? All right, so the probability of an event, that's going to be 83 over 98. And I want the odds against that event happening. Well, of course, the odds against any event happening would be this. 1 minus the probability of event A divided by the probability of event A. So it'd be 1 minus that 83 over 98 divided by 83 over 98. I'll put that over here. So 1 minus 83 divided by 98, and then hit the math key, fraction. That would be 15 over 98 for the numerator, and then 83 over 98 in the denominator. And what you're going to see here is that your 98s will divide out. You'll be left with 15 over 83. And we write that as 15 to 83, which represents the odds against an event happening, 15 to 83. Okay. All right, now let's look at this. Let's say you were given the odds and you want to compute their probabilities. All right. So if the odds in favor of event E are what we call M to N, then the probability of event E occurring would be, we take the first number that's in front of the colon, that would be your numerator, and then that's going to be divided by the sum of the two numbers, M and N. And if the odds against event E are M to N, this time it's going to be the second number after the colon. We put the N in the numerator. That's going to be the second number after the colon that goes in the numerator. That's going to be divided by the sum of the two, M plus N. Okay, so now let's look at this example. If the odds against Deborah's winning first prize in a chess tournament are 1 to 7, what is the probability of the event that she will win first prize? Okay, so let's say the probability of, let's say she wins first prize. Now, and the odds against are 1 to 7, so this is your M and that's N. So now the problem using this for odds against, we take the second number after the word 2. That's your 7. That will be your numerator over the sum of these two numbers, m and n, 1 plus 7. So we bring on the 7 and then add 1 and 7 together, you'll get 8. So the probability of Deborah winning first prize in a chess tournament would be 7 over 8. That's all there is to it. Just have to identify what m is and what n is. For odds against, we take the second number. That would be your numerator. And then add the two numbers together, that would be your denominator. All right, and here's another example of that. If the odds in favor of achieving a Grand Slam golf sweep are 2 to 9, what is the probability of achieving the sweep? The probability of getting the sweep, and the odds in favor are m to n. M is 2, n is 9. So the probability, and I'm going to come back down here to this formula here. This is the odds in favor. M is the first number in front of the colon, which is in this case, is going to be the 2. So that 2 goes in the numerator, and then we add those two numbers together, the 2 and the 9. 2 plus 9. So it'd be 2 on top. 2 plus 9 would be 11. So the probability of achieving the sweep at a Grand Slam golf tournament would be 2 out of 11. Okay. So that's how we compute probabilities when we're given the odds in favor or the odds against any event. All right, next we'll look at expected value. Now, the expected value is just a probability multiplied by the value of each outcome. Okay, sometimes you're given the value of the outcome, and then the probabilities, you'll just multiply the value of that outcome by its respective probability. And here's the formal definition. If in an experiment, the possible outcomes are numbers A1, A2, all the way down to A sub n, occurring with probabilities P1, P2, all the way to P sub n, respectively, then the expected value, or sometimes called mathematical expectation, which we give a notation as capital letter E, is given by this. E is equal to A1 P1 plus A2 times P2 plus A3 times P3, all the way down to A sub n times P sub n. Here we just multiply the probability with the value of that outcome. It's a expected value of that outcome. Now, here, expected value can be used to predict the average result of an experiment when it is repeated many times. And you see that keyword average. Sometimes they use the word mean as another way of saying expected value, because pretty much on average, what you would expect to get. Hence the word expected value. Now, expected value cannot be used to determine the outcome of any single experiment, okay? Because the experiment has to be repeated many, many times for that to happen. So let's look at this example here. Let's say 10 quarters, 8 dimes, 2 nickels, and 5 pennies are in a box. One coin is selected at random. What is the expected value of the money drawn from the box? Okay, so now, let's look at how many coins we have in the box. I get 10 quarters, 8 dimes, 2 nickels, 5 pennies. Let's see, I got a total of 25. There are 25 coins in the box. and I want their probabilities here. The probability of selecting a quarter out of the box. There are 10 quarters out of 25, so that'd be 10 over 25, which reduces to 2/5. And then there are 8 dimes, so the probability of selecting a dime out of the box would be 8 out of 25. Then the probability of selecting a nickel out of the box, there are 2 of those out of 25. And then finally, the probability of selecting a penny out of the box. That would be 5 out of 25. I can reduce that to 1/5. Now, when I do the expected value, I'm going to use cents. I'm going to express these values of each of those coins in cents. Like a quarter is 25 cents, a dime is 10 cents, a nickel 5 cents, and a penny 1 cent. So my expected value would be, the value of the quarter is 25 cents. So it'll be 25 times the probability of getting a quarter, 2/5, plus a dime is worth 10 cents times the probability of selecting a dime, 8 out of 25, plus a nickel is worth 5 cents. So it'd be 5 times the probability of getting a nickel, 2 out of 25, plus a penny is worth 1 cent times the probability of selecting a penny, 1/5. So now let's simplify this if we can. Now here I'm going to do 25 times 2 divided by 5, which is 10, plus 10 times 8 divided by 25. I come up with 3.2, plus 5 times 2 divided by 25 equals 0.4. And then 1 divided by 5, 0.2. Now my final answer is going to be in cents. So if I add 10 plus 3.2 plus 0.4 plus 0.2, I would get 13.8. And this will be in cents. So the expected value of the money drawn from the box will be 13.8 cents. All right, here's one more of these. Let's say if the odds in favor of fast leg winning a horse race are 4-3, and the first prize is $21,000, what is the expected value of fast legs winnings? All right, so here we got the odds in favor. That's 4-3. We need the probability of fast leg winning the race. So this is your M, and that's N. And if you recall, what the probability was for odds in favor is this. Odds in favor, that means it's going to be M divided by M plus N. That's the first number in the in front of the colon. So it's the 4 that's in front. So that 4 goes to the numerator. That would be divided by 4 plus 3. Bring the 4 over, add 4 plus 3, you'll get 7. So the probability of fast legs winning the race would be 4 out of 7. First prize is $21,000. So the expected value of fast legs winnings will be the probability of fast leg winning the race. That would be 4/7. times the first place prize of $21,000. So here I'm going to do 4 times 21,000 divided by 7. It will end up being $12,000. So the expected value of Fast Legs winnings would be $12,000. Okay. Now, the last thing I'll discuss in this video is fair game. When playoffs are involved and the net winnings are $0, the expected value minus the cost to play the game of chance, then the game would be fair, a fair game. That means if the expected value, and we subtract from it the cost to play the game, if that equals 0, you have a fair game. Otherwise, you do not. Like in this example, it costs $5 to play a game when 2 coins are tossed. You receive $10 if 2 heads occur, $5 if exactly 1 head occurs, and nothing if no heads occur. Is this a fair game? That is, are the net winnings going to be 0? All right, so if we were to toss 2 coins, on the first toss, it would be a head or a tail. And then if a head is tossed on the first, then the second it could be heads or tails. Or if on the first toss is tails, it could be heads or tails. So these are all the possible outcomes here. 2 heads, a head and a tail, then head, or 2 tails. All right, so 2 heads occur. That probability for 2 heads occurring, there's only one way out of 4. So it'll be 1 out of 4. And let's look at this one. If only 1 head, exactly 1 head occurred. These 2 have exactly 1 head occurring. So a probability of a head or a tail and a head. That's going to be 2 out of 4 or 1/2. And if no heads occur, that means the only way that's going to happen here is you have 2 tails. That's 1 out of 4. Now let's look at the expected value here. $10 if 2 heads occurs. That's going to be $10 times the probability that 2 heads occur. That's 1/4. Plus $5 if exactly 1 head occurs. That'd be $5 times exactly 1 head occurring. That would be 1 out of 2. So we'll do 5 times a half. And then nothing if no heads occur. The probability that no heads occur would be 1/4. So it'd be 0 times 1/4. All right, so if I do $10 divided by 4, that's $2.50. Plus $5 times a half will be also $2.50. Plus 0 times a fourth will be 0. $2.50 plus another $2.50 will be $5. So the expected value there will be $5. Now, the cost of the game is $5. Okay. So what that means here is this: our net winnings is going to be the expected value minus the cost to even play the game. The expected value came out to be $5, and the cost was $5. So if we subtract 5 from 5, we get $0, which means This is a fair game because the cost of the game does equal to the expected value of the game, or the difference between the two ended up being 0. Okay, so that will conclude this video on section 9.3 dealing with applications in probability.